Okay, so this is Edco A question 12, and it's a functions and graphs question. We've been given two functions in the question, and we're obviously going to put them on this grid here. So function 1 is f of x is equal to x squared, and then function 2 is g of x is equal to 2 to the power of x. So they're two different types of functions. You might spot that the first function is a quadratic function. And what do we know about quadratic functions? Well, we know that quadratic functions are u-shaped or n-shaped. They're u-shaped if it's a plus x squared, and they're n-shaped if it's a minus x squared. So we have a plus x squared, and so we know that the shape of that, when we go and put it on the graph, it should be u-shaped. The second function, g of x is equal to 2 to the power of x. So when x is in the power, we know that that's an exponential function. And exponential functions, are functions that start quite low and then they rise high quite quickly. And so that's the shape of that function when we go to draw it. So how do we actually go and draw functions? Well, to draw functions we need points to place on the graph, and to find points we need inputs, and then we'll get outputs from that. So the inputs are the domain. So you can see in the question that we're told the domain is -2 is less than or equal to x is less than or equal to 5, where x is a real number. And so what we're going to do is we're going to sub in the x values from -2 to 5. So I'm just going to write them down on the side of the page. -2, -1, 0, 1, 2, 3, 4, 5. I'm going to sub these into each of the functions, and then I'm going to get outputs, and the outputs are called the range, and they're going to be the y values. So you set up a table, and so on the top I have my x values here on the left hand side. I'm going to put my function in the middle, so f of x is equal to x squared if we take the quadratic function first, and then I'm going to have my y values on the right hand side. So we sub -2 in for x, so we have -2 squared, and -2 squared is +4. So when -2 is the input, the output is 4, and they become a pair of points, -2, 4, which we can then go onto the graph, go over to -2 and up to 4, and we can place it on the graph. So what we'll do is we'll find all the points for the quadratic function here, and we'll go over to the interactive then just to see the animation of the actual graph being drawn. So we sub in -1, we get -1 squared, which is +1, so the point is -1, 1. We sub in 0, and 0 squared is just 0, so we have the point 0, 0. We'll sub in 1, and we have 1 squared, which is 1, so we have the point 1, 1. We'll sub in 2, which is 2 squared, and we have 2, 4 goes out then, so 2, 4. Sub in 3, 3 squared is 9, so we have the point 3, 9. 4 is 4 squared, which is 16, so we have 4, 16. And then finally we sub in 5, and 5 squared is equal to 25, and we have 5, 25. Okay, so they're all the points that we need to draw the quadratic function f of x is equal to x squared. You're then going to go down and you're going to do the same thing for g of x is equal to 2 to the power of x. So we'll just find those points as well before we move on. So again, we're going to use the same domain. The domain, remember, are the input values. We'll just write that here. So there's the domain. And then the y values, that's the range. And when you put the inputs, the domain, and the range, the outputs together, we get the pairs of points. So let's do the same thing for the second function. So again, I'm going to put in the, let's stick to a blue pen. We're going to put in x values from -2 as far as 5. So -2, -1, 0, 1, 2, 3, 4, and 5. So I'll just have a table drawn out like this. G of x, remember, is the function 2 to the power of x. So the inputs are actually going to go in for the power in this function. And then the y values are going to be the outputs, and then we'll pair them together as points. So -2 goes in, so we have we have 2 to the power of -2. Now, 2 to the power of -2, if I just do it over here on the right hand side, one of our rules of indices says that if we have a minus power, we can have a 1 on the top place the base number 2 on the bottom, and we can make the power a plus. So that's 1 over 2 to the power of plus 2, and that becomes 1 over 4, which is a quarter. We'll just use decimals. We'll have 0.25. Now, we can use our calculator for this, and again, when we move on to the interactive, I'll show how you can use your calculator to check all these answers. When I put in -1, I have 2 to the power of -1, and again, 2 to the power of -1 is the same as 1 over 2 to the power of +1, which is 1 over 2, which is a half, and so that's 0.5. When I put in 0, I have 2 to the power of 0. We may again remember our rules of indices, where any number to the power of 0 is the number 1. That's an important rule to remember. So it doesn't matter what the number is, but if you raise it to the power of 0, you always get the number 1. We'll put in 1, we have 2 to the power of 1. Well, 2 to the power of 1 is just 2. Put in 2, we have 2 to the power of 2. 2 squared is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16, and 2 to the power of 5 is 32. And what you can see with an exponential pattern is that the numbers, the outputs, are doubling each time. So if 0.25, it doubles to give 0.5, which doubles to give 1, which doubles to give 2, which doubles to give 4, and so on. And that's one of the characteristics with an exponential series. Each term is a multiple, or has been multiplied by a common number to get the next number. We need to pair off the points, so we have -2, 0.25, we have -1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, and finally 5, 32. So now that we've all the points on both of the functions, let's go over to the interactive to actually put in those points onto the graph. Okay, so I have my 2 sets of points here, and just before I put these on a graph, what we're going to do is we're just going to use the table mode in the calculator to check these answers. And it's always a good idea that after you've kind of manually gone and entered in each of the numbers and worked out the calculations, that you go and you use table mode to check them all. So I'm going to press menu and then 3 for table mode. I want to enter in f of x is equal to x squared, so I press the alpha and then the red x for x. And I can either press the x squared button, or I can press the x with the little white box above it and put in to the power of 2. So I'm going to press equal to store that in the calculator. This particular calculator allows me to do a second function at the same time, but we'll come back and we'll do the second function. We'll concentrate on the f of x function just for now. So press equals. Start asks you the question, what's the first value of your domains? What's the first input or x value that we entered into our function? And that was -2, so put in -2 and then equals. We want to end at 5, so that's already there for us, so we press equals. And then the step, we just wanted to go up in 1, so we wanted the x values to just go up 1 each time. So if I check the answers now, I have -2, 4, I have -1, 1, 0, 0, 1, 1, press the down button to get the next, 2, 4, 3, 9, 4, 16, and 5, 25, and those are valid answers. Let's quickly do it for the g of x function. So again, it's going to bring up f of x, but I can just enter in 2 to the power of x. Similarly, you may have a question where it could be f of t, or it could be g of t, but the calculator obviously can only enter in an x value. So if we have t's in the question, or if we have some other letter, we still are obviously going to just use x. And likewise, if I have g of x, I can still use f of x to enter in the 2 to the power of the x. So I'm going to start again at -2, end at 5, the step is 1, and then I check my answer, -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. So I'm happy that all of my points are valid. Now to enter in, I am going to obviously read each of the points. The first value is the x value, and the second value is the y value. So I go over and back first, and then up and down. So over to -2 to the left, and then up to 4, and I'm going to place the first point on my graph. Then I have -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. And then you want to connect these dots not with straight lines, but with a curve. So you draw this freehand so that we can draw our U-shaped quadratic. Now you might ask the question, how come it's not perfectly U-shaped? Well, we only started the domain here at -2. If we were to go back further in the x values and put in -3 and -4 and -5, we'd have a symmetrical looking U-shaped curve. So label the graph f of x, and then we'll put in the g of x points on the graph. So we have -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. And then like before, we're going to connect these up. And we get this exponential shaped curve, which starts off, quite low. There's a gradual increase, 0.25 to 0.5 to 1 to 2, and then it doubles each time. And so eventually, even though it starts lower than the other curve, it gets higher than it, and it'll be higher than it now forever as it keeps doubling and doubling and doubling. So what we're going to do now is we're going to use the graph to answer 4 questions. The first question is, what are the 2 integer values of x for which 2 to the power of x is equal to x squared? So what they're asking us here is, what are the x values that we could put into each of the functions where the solution would be the same, or where the output would be the same? Now, if you go and you look at your table from the previous page, you might identify a couple of places where the inputs and the outputs are actually the same. And so if we go to the graph to see where that occurs, I can see that the curves cross each other in 1, 2, 3 places. And where curves cross each other, that means that the x values at those particular points give out the same y values for both curves. So only 2 of these, however, are integer values of x. We can see that the first one here, we have a value, but it's not an integer value. It lies between -1 and 0. So remember, integers are whole numbers. So positive and negative whole numbers. And so what are the 2 integer values where the inputs and the outputs are the same? Well, when x is equal to 2, we get an output of 4 for both the f of x and the g of x function. And when the input is 4, we get an output of 16 for both the f of x and the g of x function. So the 2 solutions, or the 2 integer values that give the same y values, are x equals 2 and x equals 4. Now the next question asks us, well, what's the other value that gives the same y value for a particular x value? And if we have a look, the third value lies between 0 and -1. We're going to have to estimate this, and the estimation would be about -0.77. And if you go and you sub in x equals -0.77 into 2 to the power of x, so you do 2 to the power of -0.77, and then sub it into x squared, so you have -0.77 to the power of 2, you get a similar y value. It won't be exactly the same because we're rounding off this number here. This is our best estimation based on just reading from the graph. So the answer to the third value is -0.77. And -0.77, 2, and 4 are the 3 x values that give the same y values for both curves. So the next question asks us, for what range of values of x is 2 to the power of x greater than x squared? Remember, 2 to the power of x is our g of x function, and x squared is our f of x function. So essentially what's been asked here is, what are the x values that we would put into g of x and f of x so that the outputs of g of x are greater than the outputs of f of x? Now if we look at our graph, we could probably identify a few places where the g of x function will give higher values than the f of x function. For example, if we look at x equal to 5, this gives an f of x value of 25 and a g of x value of 32. So that's one possible solution. When x is 5, g of x is greater than f of x. Well, where else? Well, anywhere that the purple line is higher than the green line, that gives greater values for g of x than it would for f of x for values of x. So we can see that any x value greater than 4, the purple line, the g of x, is greater than the green line, f of x. So that's one possible solution or set of solutions. Where else is the purple line higher than the green line? Well, we can see from here, from -0.77 as far as 2, the purple line is higher than the green line, meaning that the g of x values are higher than the f of x values for x numbers -0.77 as far as 2. And so the way that we write that is, we say that if x is between -0.77 and 2, we'll have g of x greater than f of x. So the two sets of solutions are minus 0.77 less than x less than 2, and when x is greater than 4. The fourth part of the question just asks the reverse. For what range of values of x is x squared greater than 2 to the power of x? So here they're asking, where is the f of x function greater or give higher values than the g of x function? So for what values of x? So if we go back to our graph to see where the green line is higher, we can see that the green line is higher for x values less than minus 0.77. The green value, the f of x, will give higher values than g of x. And then the green line is also higher between 2 and 4. So when x lies between 2 and 4, and we sub in values of x within that range, 2 to 4, we'll get higher values for f of x than we will for g of x. And so those are the two sets of solutions. When x is less than minus 0.77, and when x lies between 2 and 4.